conserved. Always. When is momentum conserved? It's always conserved. So suppose my son charges at me at 15 meters per second and bounces off at negative 5 meters per second. If we have his mass as 50 kilograms and we assume mine is 110 kilograms, what is my velocity? Okay, before the collision, my momentum and his momentum add up. My momentum, if we assume that I'm at rest, initially, and this is one of those things you will have to make that assumption simply because there's no information to tell you something otherwise. Uh, if in fact I were not to assume that, then on a test, for example, if you didn't assume that, you'd kind of be stuck as to how to do that. You might make the assumption anyhow by saying my momentum was zero. Uh, Normally, I would expect you just to say assume that I'm at rest or something like that and leave it at that. So my momentum is going to be mv, which is zero. His momentum is going to be 50 times 15, which is 750, right? There's 750, I believe. Yeah. Now the units on momentum are simply mass times velocity, or kilogram meter per second squared. The after the interaction momentum is still going to be me plus him. Okay. Now, my mass is 110. Here, since I assumed that I was initially at rest, we didn't even worry about my mass. But now I'm going to have my speed. We now know that he has a mass of 50, and then his velocity is going to be a negative 5. So 110v plus a negative 250. So this is going to be 1,000 equals 110v. So that my speed is going to be approximately 9.09 meters per second. Now in this case, we have we have one significant digit, 2, 1, and 2. So in fact, I should only have one significant digit for my answer. So my final speed, my final velocity, which would be presumably in the horizontal x direction, would be 9 meters per second. A stink bug of a mass of approximately a gram smacks a balloon with a mass of 1/10 of a kilogram at rest, and they travel off at 1.25 meters per second. What was the initial velocity of the bug? Well, before, you had a balloon that was at rest, so its momentum was zero. So you had the momentum of the bug plus the momentum of the balloon. So this is going to be 0.001 times 1.25 plus 0 equals the momentum after. Now, they travel off at 1.25 meters per second. In other words, they're sticking together. So I'm just going to call that the total momentum. Well, this is going to be the mass of the bug plus the balloon times their combined velocity, which we know. Oops, we didn't know the initial velocity of the bug. We knew the final velocity of the combination. So we know that 0.001v is equal to 0.101 times 1.25. So 0.001V equals 0.126. So this bug was 126.25, and if we look, we should only have, in fact, one significant digit. So really, we should say it was about 100 meters per second. Now, I'll be honest, I do not know if that is typical speed for a stink bug. They're quick sometimes, but I've never actually tried to measure the speed of one, nor have I attempted to measure the mass. These are all just ballpark estimates.